So in this section, we're going to learn a little bit about pulmonary function tests. And in order to do that, we need to breathe. So I got my trusty little whiteboard and I'm going to show you how the graphs are made. So is everybody ready to start breathing? Okay, just take a normal inhalation and then a normal exhalation. And then another inhalation and another exhalation. Now breathe in again as much as you possibly can. Okay, now blow it all out. Keep on blowing, 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 blow it all out. And then take another inhalation and exhalation at the end. So as you can see, we have a graph where all the upward deflections are inhalation and all the downward deflections are exhalations. And from this area, this is a normal breath in. This is extra air we can breathe in, and this is extra air that we can exhale. So what does this mean? Well, these are measurements that we do on people to look at their lung functions. And we are going to be, we're not going to in lab, obviously, but we can measure these volumes. But you have to realize that the volume of somebody like LeBron James is going to be totally different than the volumes of somebody like Simone Biles. They're totally different sizes and sexes. And height is a really big determinator for these different lung volumes. So there's all kinds of tables of what is normal, and we're not going to bother learning any specific details, and we're just going to kind of keep it very generalized and give average numbers. So let's get started. And where we are going to start is with lung volumes. Now, a lung volume by definition is something that we can actually measure. So there are several lung volumes we can measure. The first one is called the tidal volume. So if you go back to when we were breathing in and out, the amount that we were breathing in and out with just a normal breath, that's the tidal volume. It's like the tide. It comes in, it goes out, and it comes in, and it goes out. And so while you're sitting here doing much of nothing except listening to this video, you are moving about half a liter. This amount of air, not water obviously, but that amount of air in and out with each breath. Now, after that normal inspiration, you saw that we were able, normal inspiration here in yellow, we were able to take a significantly larger breath if we needed to. We don't normally breathe like, okay. So we do have this extra reserve volume called the inspiratory reserve volume, which by definition is after a normal inspiration, the extra air you inhale when you inhale as much as possible. And this is about an extra 3 liters of air. Could be slightly more, could be slightly less, depending on your size. Similar to the inspiratory reserve volume, we have an expiratory reserve volume. And the definition is exactly similar. After a normal exhalation, this is the extra air that you exhale when you exhale as much as possible. So think of that extra air you're exhaling when you're trying to blow out birthday candles, for instance. And this is slightly more than a liter, depending on your size. But stop and think for a second. When you blow out everything you can, is all the air out of your lungs, your airways? Think about that balloon. If you're blowing up a balloon and you let drop and all the air kind of comes out, is that balloon completely collapsed down, 2 pieces of plastic next to each other? Or is there just a little bit of air left between them? That's right, there's always air left in your airways. Our alveoli do not completely collapse down on each other, nor do our bronchioles and bronchi. You know, some of them have cartilage in them, which prevents them from collapsing down. So even when we maximally exhale, there's always air left, and that is called the residual volume. So the air that is left in your lungs after you exhale everything that you can is the residual volume. And once again, this is about 1 liter to 1,200 cc's, depending on your size. So that's it for the volumes, which brings us to something called lung capacities. So the volume was an actual measurement. Now, when we take some of those volumes and we put them together, they give us a capacity, which gives us even more information about your lung functions. So the first capacity is the inspiratory capacity. And for this one, after a normal exhalation, so when you're starting down here at the bottom, the total amount of air you can inhale is called the inspiratory capacity. So that includes the tidal volume of inhalation as well as the inspiratory reserve volume. And as you can see, this is going to be about 3.5 liters. The second capacity is the vital capacity. And the vital capacity starts up here at the top. So you've already taken a maximal inhalation. So after a maximal inhalation, it is all the air you can exhale. So it includes the inspiratory reserve volume plus the tidal volume plus the expiratory reserve volume. And as you can see, it's quite a significant volume, over 4.5 liters. The reason why this is an important number is because this represents all the air that you can move. So it represents the amount of air that's available for gas exchange between the air in your lungs and the gases that are going to go into your bloodstream. And what's interesting, with proper training, athletes can increase this vital capacity by at least 1/3, if not 40%. And this makes all the difference when you're competing, especially for more than just a few seconds. Another capacity is called the functional residual capacity. And for this one, we have a normal exhalation, and what we are looking is how much air is left in the lungs. And so what that is going to involve is our expiratory reserve volume plus the residual volume. So this is air that we are not exchanging in our normal exhalation. It still has some gases in there that could get some gas exchange going, but it's the air that just kind of sits in there and holds things open. And then our final capacity is the total lung capacity. And this one's really straightforward. From here to down here. And so after a maximum inhalation, not only the amount of air that we can move, but include the residual volume that's down there. It's the total amount of air that we can possibly put into our lungs. So it's the inspiratory reserve volume and the tidal volume and the expiratory reserve volume, which all three together form that vital capacity, plus the residual volume. So with that, we're done with all of our lung values and capacities. So make sure you understand the differences between them. And I'll see you again soon in class. Thank you.